My name is Brandon Fahry. I'm the Senior Contracts Manager from SAISC Steel Fabrication. Okay, on Omnia we had to use specialized sections, so we had to do purpose-made plate girder columns, which were made from 30mm material and submerged welded. We also had certain sections with beams where the spans were a bit long, and with the weight that they would be taking, we had to use 1.4 meter deep plate girder beams, which were also made out of 20 and 25mm plate. The rest of the sections were all universal beams, RPEs, made up the framing for the floors. There were specialized tubular bracing systems that were put in place, obviously to distribute the loads, the massive loads on that structure. Due to the highly corrosive environment, we had to use 3CR12 lip channel purlins and girts around the structures, and no material was under 3 mils thick on this project. The challenges that we had on Omnia, with it being obviously an operational plant around where the construction site was obviously there had to be proper planning in place with regards to getting to materials on site, as our laydown area was actually 1 kilometer away from where the steelwork was being constructed. Being that with the spacing that was allocated to the site and the pure magnitude of the structure, there wasn't much space for us to maybe establish tower cranes, which would have been a lot more useful on the project. But because certain elements couldn't be in the way constantly, we had to use a lot of mobile cranes to install the structure, and obviously working around other trades and the existing work in the workshop. So what we did with Omnia is that we're actually quite proud of our quality control systems in place in the workshop. We actually increased our quality control in the workshop. Basically, we checked every single element before it went out to site, to the sandblasters, just due to because Omnia is a highly corrosive environment. They've got specialized coating systems. So it's a phenolic epoxy system which they've got going. And in order for us, we had to try and eliminate a lot of site works. If anything had to arise, it compromises the coating system. I think what the steelwork and what the design on Omnia's new Nitrophosphate plant highlights is basically just how much we can do with steel, whereas we wouldn't be able to do with concrete. Using steel was a lot more cost effective on the structure, because the structure is 42 meters high, and it just opens up the Nitrophosphate plant for expansion. There's a few aspects that I'm proud of on Omnia. I'd like to start off with the safety. We had a full-time safety officer monitoring every single procedure that we did. And this was basically due to, just because of the time constraints on the project, there were 600 other employees working around us, under us, over us. And there was less than a 1% incident rate on the Nitrophosphate plant, which is really commendable over the time that it's been there. The project's been going on for. Another aspect that I'm very proud of with Omnia is he's been a man that loves steel. To just go and see the magnitude of the structure and seeing the steel elements, it made me very proud to see elements that I haven't seen in years, put it that way. And 42 meters high, the way we had to install the structure. I also only had about 30 guys on site, and we had to have the main structure completed in 6 months. So we really did put in a lot of effort to getting the structure up and going.